All right, I'd like to spend a bit of time talking about retention time calibration and retention indices. And the goal here is to make the tools that center around library searching more useful, and those include unknowns analysis, perceived compounds, and new method from acquired scan data with library search. So here we've got an example of its use. And if we broaden this picture out, you can certainly say that mass spectrometry with spectral matching is quite useful. But there can be confusion because spectra look similar. So by combining both the spectral match as well as the retention time match, that drastically improves the hit quality of library searches. So the question that we're going to face here is, how do we keep those retention times lined up with the library? So to answer that question, it's certainly worth mentioning you could employ retention time locking, and that works quite well if you have a fixed separation method. But in this, I will talk about retention indices and improving the identification using library search. So retention indices is basically creating a mapping that allows you to deal with retention time shifts. The classic example is a shorter column because you've just cut it. And that mapping, when we use retention indices, will allow us to correct for that shift. This is showing you the classic N-alkane series in the Kovatz indices, which is often used, but the approach is independent of the series that you're going to use. All right, let's look at the definition of retention index. That is a number obtained by interpolation relating the retention time of the compound to retention times of, let's say, two markers which elute before and after the peak, the target peak that we're looking for. And typically that graph looks something like this. It's not necessarily linear, that's why it's interpolated. So our goal here is to use these retention time indices to enable what I'll say is retention time normalization. The trick being, create this relationship, this mapping between retention indices and retention time, allowing this time correction. So with this updated mapping again, you can locate a compound in the library, and if the library stores that retention indices, and you've created this mapping with the retention time calibration tool, which I'm about to show you, you can then use retention indices as additional constraint on that library search. The advantages of retention index are significant. Certainly, as just discussed, when the column length changes, as if you're cutting your GC column, the retention index is independent from that. And if you had to change for reasons of separation your isothermal or your linear temperature ramp, and you were varying that, also this enables an independence from that change if you're employing retention indices. There are other reasons, but let me just jump to the library is kept immutable because the retention indices are in the library, and this mapping that you're creating, which needs to be kept up to date. Let me mention that there is much more detailed information. If you go to a search engine like Google and type in retention time index, you'll come across an explanation of the kinds of series or ladders that are used in the industry. So let me get to how MassHunter implements these concepts. First, there needs to be in place some assumptions. Let me go through that. First, you already have created or have purchased a library that has the compounds, including the marker compounds, and there are retention indices in that library. You have made an injection. You have a data file that exists that contains those marker compounds on your particular instrument. And last, you've taken that data file and you've created a quantitation batch that contains those marker compounds, their compound names, and you have that ready. The tool that I'm going to show you next, which is the retention time calibration tool, is going to need that batch with the compounds identified in order to create this mapping that we're going to store down here. So those are the assumptions. I need a library. I need to have that batch file. I need to know where I'm going to put the mapping to use to do the library searching. Is the mapping back to retention time and retention time normalization?